At this point, we are now ready to solve rational equations. Like in any other types of equations, our goal is to solve for all the possible values of a variable. We learned that there may be restrictions in our solution set when we deal with rational expressions. We pay attention to these and make sure that the values we generate do not generate undefined answers when substituted to the expression. Let's start with a simple example. In this case, we want to determine x if 1 over x plus 1 over 4 is equal to 1 over 6. There are a bunch of ways to solve this problem. What is generally used, however, is quote-unquote getting rid of the denominator. This is achieved by multiplying both sides of the equation with least common multiple among the denominators. The least common multiple of two numbers is the smallest number that is evenly divisible by such numbers. In this case, our denominators are x, 4, and 6. Their least common multiple is 12x, since x, 4, and 6 can all divide 12x, meaning 12x is the smallest number which, when divided by x, 4, or 6, does not give us any fractional answer. We multiply both sides by 12x then. We distribute 12x to each term and get 12x over x plus 12x over 4 equals 12x over 6. We then simplify each term, dividing what we can divide and reducing what we can reduce. We end up with 12 plus 3x equals 2x. This is now relatively easier to solve. We use subtraction property of equality. We subtract 3x and 12 from both sides, giving us 3x minus 2x equals negative 12. Simplifying, we finally get x equals negative 12. Let's do the same thing with our next example. In this case, the number that both our denominators, x and x plus 2, can divide is x times x plus 2. We multiply this to both sides of the equation. Distributing x times x plus 2 to each term, we get 10x times x plus 2 over x plus 14x times x plus 2 all over x plus 2 equals 4x times x plus 2. We then simplify. We now have 10 times x plus 2 plus 14x equals 4x times x plus 2. By distribution property, we get 10x plus 20 plus 14x equals 4x squared plus 8x. Since this is a quadratic equation, this gives us a hint to equate this to 0. We subtract both sides of the equation by 4x squared and 8x, giving us 4x squared plus 10x minus 8x plus 14x plus 20. Simplifying, we have negative 4x squared plus 16x plus 20 equals 0. Simplifying further by dividing both sides by 4, we get x squared minus 4x minus 5 equals 0. We now factor x squared minus 4x minus 5 equals 0. The factors are x minus 5 and x plus 1. By principle of zero products, we equate x minus 5 and x plus 1 by 0 separately and solve for x. This gives us x equals 5 and x equals negative 1. Since these numbers do not make any of the rational expressions undefined, then these belong to our solution set. Let us now have our final example. In some cases like this one, it's helpful if we completely factor the denominators to easily identify the least common multiple. We see that n cubed plus 5n squared may be factored as n squared times n plus 5. Looking at this equation, it gets clear that the least common multiple is n squared times n plus 5. Meaning, when we divide n squared times n plus 5 by n squared times n plus 5, n plus 5, and n squared, we would not get a fractional answer. We now multiply both sides by n squared times n plus 5. Distributing this to each term, we get 5n squared times n plus 5 over n squared times n plus 5 equals 4n squared times n plus 5 over n plus 5 plus n squared times n plus 5 over n squared. We simplify this equation, canceling out n squared times n plus 5, n plus 5, and n squared. We now get the neater equation 5 equals 4n squared plus n plus 5. Like what we did with our previous example, we equate this to 0 by subtracting both sides by 5. Simplifying, we get 4n squared plus n. We can factor this out as n times 4n plus 1. Again, by principle of zero products, we equate n and 4n plus 1 to 0 separately. This gives us n equals 0 and 4n plus 1 equals 0. We solve for n plus 1 equals 0 to get n equals negative 1/4. Now, if you try plugging in n equals 0 to our rational expression, you would get an undefined expression. Therefore, n equals 0 is an extraneous solution. The only possible value of n in this example is negative 1/4, and that is our solution set.